All right, who wants to read the objectives for us? Nice and loud, nice and loud. Austin, right? Francis. Close. Sorry. I'm working on it.
Review methods of simplifying algebraic expressions. Evaluate algebraic expressions.
Okay, now, question for you. Before we start, who can tell me the difference between an expression and an equation?
An equation has an equal sign.
Good. And what are on each side of the equal sign?
Equal.
So what are just-
I don't know.
I'm asking you to tell me the difference between two things.
Yeah.
What was the other thing?
Oh, equal expression.
Yeah, that's what it is. When you take two equal expressions and put an equal sign between them, you get an equation. Okay? So an expression is never going to have an equal sign if you call something an expression. The minute there's an equal sign, it becomes an equation. Okay? Make sense? All right. So we have some definitions. You don't have to write them. They're on here already. Can I get a reader? Can I get a reader for us? Natalie.
Numerical expression, a symbol or group of symbols used to represent a number. Value, the number represented by the expression.
Go to the first three. One more.
Equation, a sentence formed by placing an equal sign between two expressions, thus making them sides of the equation.
Okay, these should all be things that you've seen already, right? Any questions? We're good? Okay, just to reiterate. Let's go to inequality, the last two. Last two.
Inequality symbol. Symbol that indicates that two expressions are not equal to one another, with the exception of,
Less than or equal to?
less than or equal to or greater than or equal to.
Perfect. Okay, because less than or equal to, it could be equal to. Okay, that's where the or comes in. Inequality.
Inequality. A sentence formed by placing an inequality sign between two expressions, thus making them sides of the inequality.
Okay. Any questions, right? We're good? Okay. First one, very simple. Take your choice. Less than, equal to, or greater than. Take 1 minute. Go ahead. We're going to do a quick vote just to see if we make sure we're going to write something. Okay, you're at 1 minute. Try to work a little quicker. Just giving you an idea of pacing out tests. Should only take you about a minute, maybe a minute and a half for this kind of problem. Again, you could use a calculator. I prefer you not to for something like this. All right, hands for less than as an answer. Less than. Hands for greater than as an answer. Okay. Now, for this kind of a problem, what are you doing quickly?
Simplifying.
Yeah, just simplifying each side. What do you get here?
You get 13.
And here?
11.
Good. And 13 is greater than 11. Okay? Now, remember, when you simplify, you have to remember what acronym or what thing that you have to do? PEMDAS, order of operations. Okay? Order of operations. Why does order of operations matter?
Because if you did it a different way, you get a completely different.
Yeah, you get a completely different answer. One way is, in mathematics, there are fields where you'll get more than one answer. But for something like simplifying an expression, there's only one answer. Now, when you start changing things up and doing things almost like not following rules, you get different results. Those results are not true results. So you have to remember to keep order of operations in your mind. Divide here first, then add. Square first, then subtract. Quickly, the word sum is when you're adding, product, you're multiplying, difference, you're subtracting, and quotient, you're dividing. Keep those words in the back of your mind. Okay? Power, the product as a result of equal factors. What does that mean? Product as a result of equal factors.
Like it would be like if you multiplied 2 times 2 times 2, that would be 8, and that would be 8 to the third power.
Perfect. Perfect. Very good. So 2 times 2 times 2 is really 2 to the third, which is really 8. Okay, the product as a result of equal factors. The base is the repeated factor, so that would be 2 in that case. The exponent would be the 3, the number of times the base occurs. Any questions on this? Okay, good. This is something that's almost like second nature, but we do have a name for it. Okay? It's called substitution principle. If something is equal to another thing, you can replace it with it. So in the middle of an operation, if you have like something in parentheses where it says 11 minus 7, you can replace it with 4, right? 4. So you can put a 4 in there. That's what this is, really. Now, it seems like it's like, why are we even going over it, right? When you get to variable expressions, it is very useful. For example, imagine that you're working on like a rocket for NASA, and you have to do some work, and you're realizing that you do everything, and you go through all the math, and you have everything in terms of the radius. You realize that the computer input of the system is everything in terms of the diameter. But you don't want to actually change the number because it's a function of time. So for example, imagine a radius that changed as time went on. So if you had like a conical object. So imagine if this were not a cylinder but it were a cone. So the radius was getting larger as it went up. Okay? And you started filling with water. The radius of the water level is pretty small toward the bottom, right? And what's happening to the radius of the water level? It goes up, it gets larger. So it's a radius that changes as a function of time or height. So in this computer program, maybe you can't suddenly just put in a new diameter. You can't say the radius is 7. Okay, well the diameter is 14. That would be very simple, right? So what do you do instead in your computer program? If you can't put in a number, instead of replacing a number for the radius, what can you replace the term r with? What is the similar or expression, the same expression as r in terms of variables? What would it be? Think about how is R related to D? How is R and D, are they related to one another? The diameter is twice the radius. So wherever there was an R in the program, what should you put in?
2R.
1/2.
Half D. Think about it for a second. Yeah, you went the other way. I know what you mean. You did replacing D with 2R. But what do you replace R with would be 1/2 D. If there was D in the program already, the diameter, how do you replace that? 2R. And that's what you would do. Okay? So the idea of substitution principle seems like, well, who cares? But it actually is very valuable. Okay? That's the kind of thing I want you to think about. Order of operations. Quickly. We're doing this first, we're doing this second. Agreed? What happens with the next ones, though? What happens with multiplication, division, addition, subtraction? Whichever comes first. What do you mean, whichever comes first?
It says, like, you divide by 3 times 2, you do division first.
Okay, so when reading from left to right, whichever comes first. Good, agreed. Does that make sense? So the example we had here,
2 divided, I don't remember it, 2 divided by 3 times 5.
5. Okay. What do you do first? Because it appears first. Even though the M comes before the D in the word PEMDAS, these are grouped. These are grouped. So because division occurs first, you do that. Same goes for addition and subtraction. Okay, but you do addition and subtraction after multiplication and division. But the same occurs for these two as a pair. Do addition before subtraction only if it occurs first. You may do subtraction before addition if it occurs first. All right. Example 2. Go ahead and simplify. See what you get. Let's do this. Go to a new page and write your answer in big letters. And we'll all hold it up at the same time and I'll see if people did well. It's like a mini whiteboard, right? In my last school, I taught in DC, I got a lot of little whiteboards. Or I got like a panel of this, and I took a saw pretty much and just cut it up into little pieces. So the kids would have whiteboards in class. So we didn't have iPads, but yeah, it worked pretty well. It's not to catch you, it's just to see how people are doing, you know? I'm not looking to see if you get it wrong, I want to see if you can improve. Show of hands, how many people need a little more time? Okay, keep working. Take about 20 seconds or so. Yeah, you can even try it on my iPad. Can you do the work real quick?
Yeah, sure.
Yeah, copy your work real quick. Hey, take a look, please. Check your work. So, first step was simplify what's inside the parentheses. Second step was to cube what was in that parentheses. Third step was to divide 27 divided by 9. Fourth step was to do subtraction of...
Well, I come to the second one, I come to the 3 times 6.
Say again?
So for the second.
Oh, okay. So what Georgia did, interesting Georgia, that works too though. What she did was this. She put these two together first, like that. And you can do that, that's fine.
Oh, yeah, no.
She combined these two quantities to give -6, and then did 3 and -6. It's the same as doing 3 minus 18, giving you -15, and then adding 12 to that, still giving you -3. That's fine. She introduced her own set of parentheses, which is okay then. You get the same answer. But again, the alternate way would have been to, how do I go back? Undo.
Would have been just.
That doesn't work apparently. The alternate way would have been to go and do 3 minus 18 is -15 plus 12, which still yields -3. Same difference, they're both right. Okay. Any questions on that problem? I know some of you have mistakes, so make sure you look and understand it. Please don't just nod. It's not going to help you, it's not going to help me. Because I'm going to think, okay, everybody's got this. And then the test's going to come around and I'm going to see a lot of mistakes. So I don't want to, you know what I mean? Have to worry about that. I'm assuming everybody's okay with this right now. Please ask if not. All right, quickly, define a variable for us. A variable here. Take a look, read through it. Okay, make sure that makes sense. A symbol, usually a letter, used to represent any member of a given set. And this is called the domain of the variable. Where have you heard domain before? Where have you heard domain before, Francis? Okay. In graphing in general. Yes, involved in parabolas for sure. What is the domain when we're talking about graphing? For graphing.
If you have like a group of like coordinates, it's like all the x-axis in order from like least to greatest.
Very good. Exactly right. It's all of the values that x takes on from least to greatest. in some sort of ordered set. Now, a variable has a domain. It just means that it can be a certain range of numbers. So if x is a variable that's a real number, it means it can be rational, irrational, it can be an integer, it can be a whole number, it can be a natural number, all those things that we talked about last time. Okay, so that's all the domain part is there. Let's take a look at an example here. Evaluate the expression below if x is 7, y is 6, z is 3. Go for it. Guys, there are two ways to do this, I've noticed, which is fine. You can make them into mixed numbers and add them together, or you can make them into improper fractions and find the common denominator and add them together. Okay, either way is fine. Some of you do it different ways, they both come out to the right answer. Name, sorry. Adam, right? Adam? Can you put it on the iPad? Just go up there and write it right on my screen right there. Thanks, Nicole.
On the smartboard?
No, on the right there. Stylus is right next to it.
Oh, anyway.
You can compare it to this number, right? You don't have to. At this point in time, we just find common denominator. So it's 6 down. Double that, one second comment. So then 26 plus 10 is? Plus 36 over 6.
Why can't I do this? Why can't I?
Don't go to mixed numbers. If you have trouble with the mixed numbers, you know what I mean? It makes it more complicated. I got you. Good. Okay, so guys, the easiest way to do it is the way Natalie's doing it right
Can
now.
I erase it out 3 instead of 6? How do I erase?
Yeah, so eraser is...
Oh, there you go. And then go back to pen.
And you can scroll down by going like this.
Oh, thank you.
And then go back to pen.
Okay, thank you.
So again, this is by far the easiest way. You can add
do that
mixed
right?
numbers together, but it seems to be more room for error. If you like mixed numbers, then add them together. If you're good at it, it's fine. But I would choose this if I were choosing an easy way. Any questions at all? All right, good. Last one for the day. Let's see who can do this. And there's multiple answers, so you can raise your hand as soon as you get an answer. See how many we can get. Use 5 2s and exactly 5 2s to write an expression whose value is 7. You can use any operation, multiplication. multiplication, division, you can use fraction, you can use exponents, you can use square roots if you know where the 2 goes.
Oh, that makes
But I need expressions that come out to be 7 using 5 2's. And there are many possible solutions. Only 5 2's. Worth, you're up first. Here you go.
Yep.
No, you gotta use 2's.
What?
Only 2's, no 5's.
Wait, but can you?
Oh, I'm just really tired right now, I'm sorry.
That's alright, Worth. Don't worry about it. So guys, you could do like 2 plus 2 plus 2 or 2 to the 2 or 2 over 2. You gotta use the number 2's.
Oh, 2 over 2.
Liam. You could do 2 times 2 times 2 times 2, yes, but you can't use the number 4. You want to read it to me? I can write it.
Okay, I did 2 plus 2 plus 2 plus 2 over 2.
Very good. That's the easiest one right away. Well done, Hannah. Well done. 5 2's have been used to add up to what? 7. Okay? Let's see what else we got here. Just try stuff. Don't sit there. Just try it. Write anything down. Write 2 times 2 or 2 to the second. Write stuff down and try it and see what happens. Worth, go.
Okay, so 2 times 2 plus 2 times 2 wait a second. What did I?
You were close in the beginning. You could have started the way. Anybody will help them out from here? You could start with 2 times 2 for sure.
Yeah, no, I see.
You got it? You want to go?
Yeah, then times 2 again. Oh yeah.
Yeah.
Minus 2 divided by 2.
Very good.
There we go, that's right.
There's another one also to start with, 2 times 2. Got it? Or you had the same one? Okay. George, you had?
Yeah, so 2 times 2 plus 2 plus 2 2.
Yeah. Just alter the first one. Because isn't 2 plus 2 the same as 2 times 2?
Yeah.
It's the only thing that works that way, right? Isn't that kind of cool?
You got 2 or 3.
Oh. Wow. There we go. Next. There's more. Come on, people. Use versatility. Take the first one and change a little part about it and you can do it again.
2 to the 3rd minus.
Can't do a 3. Can't use the number 3. Weak. Come on. You can do a few more.
2 times 2 times 2 times 2 minus 2.
No. 16 minus 2, that gives you 14.
Oh, we need 4. Oh, we need 7.
7.
Why did I think we needed 14? I've been trying to do 14 this whole time.
That doesn't work.
2 times 7 is 14.
Yeah, I know. That's what I was trying to think.
The number connection.
Yeah.
How about 2 to the second and the same thing as the beginning?
No. Okay then.
Oh no, wait, I'm wrong. I'm wrong. Because what did I do? I used an extra 2.
Over 2. You should do
Yeah.
over
Oh, there we go. Never mind.
That's
I was about to press the plus. Anything else? We could stop there, but I'm sure there's a few more. If you think of any more, let me know, because I'm curious how many we can actually get. Oh, because we're not trying. It's got to be a good amount, a few more. Tonight your homework, it's on Moodle. It's already up there. You know what I do sometimes? I put the homework up for the whole week. So please use the due dates. I might put the homework up for all of next week. So don't look at the last homework. Look at the homework that's due, for example, tomorrow. Okay? You guys have off on day 6, right? Okay. So your homework's here. This is on page 5. Is that what I wrote?
Yeah.
Okay. Oh, it's from. It's a nice review from the first.
We have to do this.
Yeah. So guys, every one of your homeworks is going to be homework from the unit we're on, or section, and then some sort of review. So these are like 5 questions from section 1-1. When we get to like section, 4-8, we're going to do something from chapter 2. Just to move around. Can somebody erase the boards or come around and erase, grab the eraser? So multiples of 3, guys, yeah, does that make sense? So 9, 12, 15, 18, 21, 24, 27. You'll know your multiple, right? If you go back to your hands when you do there. There is the multiple. You're welcome. You figured out the chemistry thing?
Oh my god, that was so nice. I
That's alright. No, it's fine. I just didn't want you to think.
Thank you, Mr. Howell.
Have a good day, Worth.